Good morning, everyone, and thank you for attending. Hang on just a moment. So, great. Thank you, Microsoft PowerPoint. So today's presentation is on microsegmentation, specifically that IoT ICS security is more than microsegmentation. Excuse me. So Enclave, ended up developing a zero trust communication platform. We decided that our goal and our mission was to protect our most vulnerable attack surface, which we consider to be critical infrastructure. Part of our development, we used existing technologies and leveraged those technologies from the IC community as well as DoD, and we then modified that for creating a zero trust purpose-built platform to run and protect enterprises. In addition, our platform accelerates enterprises to move to a zero trust framework with a single integrated solution that is more secure, easier to manage, and lower cost than traditional IT approaches and technologies. What we will cover today: the real problem we face in protecting critical infrastructure and why we chose a zero trust model. Number two, the second part will be development overview of the Enclave Trusted Platform. We will then go to how the Enclave platform works and how it is applied to an IoT ICS network. And lastly, I will provide a short demonstration of critical components of the Enclave Trusted Platform. Why rethink cybersecurity? Because what was working isn't working anymore. Yes, there have been an increase of attacks and on converged, and we know that converged infrastructure is vulnerable. Based on information from the U.S. Office of the Secretary for the U.S. Department of Defense, OT assets within the DoD are 2.6 billion endpoints, potentially 90,000 different operating systems, many legacy devices approaching 30 years in age. A number of them being legacy do not have IP addresses, so 60, possibly 80% have IP addresses, the rest do not. And the perspective that network manageability was impossible or next to impossible. We determined two conclusions. One, that the endpoints are too complex and diverse to protect with IT tools, too expensive to replace and increasingly hard to manage, and that converged networks are overloaded with OT, adding more devices increases risk, complexity, and cost, and it won't solve the problem. So our zero trust solution, we ended up aligning with the NIST standards, NSA, and the MITRE attack architecture and recommendations. We look at zero trust not as a product, as a framework and a way of life. We incorporate and integrate techniques, approaches, and technologies that we've leveraged from the IC and the DoD. Next is what we would consider characteristics of an ideal cybersecurity approach. Zero trust. Never trust, always verify both inside and outside the corporate network perimeter. Value-based asset protection, trying to determine or quantify the value of corporate assets, whether it's data, services, brands, and impact of security breach on these assets. Next would be security by design, having an integrated approach for IT, OT security with a formalized infrastructure design and automated security controls from the ground up. The next part of that would be microsegmentation by reducing the attack surface by placing security perimeters into small isolated zones with different access privileges. Then cyber resilience and device detection, situational aware continuous monitoring, detection, and containment. The technical aspects of this cybersecurity approach will be highlighted during this presentation. What are the parts that we consider of a dynamically managed private network? And we look at it as a puzzle. Zero trust, where we have trusted identities, services, and devices with the Enclave custom rule learning engine. Layer 2 over layer 3 encryption, which basically creates an unbreachable point-to-point communication. Certificate management with our dynamically managed cipher key system using a blockchain and our own root of trust. This is a private blockchain, and we've made extensions to Sawtooth Hyperledger and for multi-segmentation in the blockchain to improve performance and to archive data that isn't necessary. And lastly, microsegmentation, which is isolating segments of a network with select access privileges. So this slide is what we would consider a water treatment plant example. In this slide, you'll see the different sections, whether it's the field engineers, remote employees working from home, who need secure access, and we're providing a solution that replaces traditional IPsec VPNs. On-premise employees, IT systems and cloud-based solutions that are incorporated, a central control, network operations center or security operations center, the actual automation systems, the physical security, and the actual operating water treatment plant. This slide is we're going to start illustrating the highlights from the development of the Enclave Trusted Platform. In May of 2017, we were tested at the National Cyber Range in Orlando, Florida. Why is this significant? Well, it wasn't that we just succeeded, but we had to use outside of the box thinking. We determined that IT methods are not sufficient to monitor IoT ICS, and then communication is key, not just within Enclave, but within our partners, within the organizations that we're working with. We learned that because this was a unique environment, that there were pieces that were missing, that if we didn't have proper communication, we wouldn't have been able to succeed. The next part in the development that was very important was DEF CON 26 in August 2018 at the ICS Village captured the flag. Again, why is this significant? We had a secured access camera that was the only device not hacked. However, we did learn critical lessons. The first one being scalability. Our existing root of trust was not scalable. We needed to develop virtualization both on-premise and cloud, and we needed to improve ease of deployment. Again, back in 2018, this was our first generation product, which we have moved away from. The second lesson that we picked up was monitoring. We needed an API-based integration with our Zero Trust. We needed that was required, and that alerts from monitoring must be actionable. Having a separate monitoring system that doesn't allow you to integrate back with our control system makes it more difficult. And lastly, that partnerships are critical to success. So because of these developments, we decided to work on our secure blockchain as our new root of trust. We did our first deployment in September 2019. Again, why is this significant? We decided that a private blockchain was the best trusted root authority for a zero trust network. Scalability to support potentially millions of trusted devices. All Enclave Trusted Platform components are registered to the blockchain. Devices that are not registered and approved by an operator cannot connect to secure enclaves. Next part was development of multiple platforms for trusted broker and trusted edge devices. I'll get into a deeper description of what components make the Enclave Trusted Platform momentarily. Virtualized servers, whether it's ESXi, Hyper-V, Azure, AWS, DigitalOcean, ACAP cameras. We've worked with Access Communications to embed our software on the camera directly so that it becomes a trusted device. Python-based Raspberry Pis and other single board computers with and without Wi-Fi support. iOS and Android-based secured phones for remote access. We're currently testing this right now. And the next part that we'll be testing soon will be the Windows app for remote access, taking a laptop, desktop, and allowing it to be a secured endpoint into an Enclave environment. So why blockchain? Blockchain allows for assurance that the data we get can only come from a correct device. These statements come directly from the device on a secure, trusted connection to the blockchain. In addition, the data cannot be tampered with. Therefore, we have assurance that we understand how the device is set up currently, as well as its complete history. We develop multi-pathing, allowing for quick access of all of a device's data on the blockchain. We then have also developed multi-segmenting, allowing for old data to be archived, but maintaining the integrity of the node. Additional information hosted by our blockchain nodes. Nodes also host information which gives insight into the state of the blockchain and allows quick access to see the blockchain data. Nodes choose when to segment the blockchain, allowing for data to be archived. Archived data that is segmented is still represented on the chain, so chains with segmented data are still able to act as full nodes, write to the blockchain, and confirm other nodes that host the full blockchain. How it works, part 1, our patent-pending solution to dynamic cipher key management. DCKM uses a process that distinguishes itself from prior cipher key issuance and management solutions and is applied via the following components. First is the Enclave secure blockchain. Multi-segment private blockchain securely holds the cipher keys used to establish a trust between our other devices, the device states, and authorized user information. The Enclave Administrative Console, which manages the ISO images and registers all Enclave devices, orchestrators, trusted edges, trusted brokers with the Enclave secure blockchain. The Enclave Orchestrator Console. It's our secure management software. This is actually, I call this in practice our policy engine. It establishes the linked communities of interest by the secure ID of each participating enclave. I'll be demonstrating the Orchestrator Console shortly. The Enclave Orchestrator Console can establish a spoke and hub or a point-to-point mesh connection or a combination based on need. Once installed, the Enclave Orchestrator Console becomes a secure and trusted appliance linked to the Enclave Trusted Broker and will only operate with the trusted brokers it is paired with. This maintains security and prevents trusted brokers that are owned by another organization or within the existing organization that are managed by another group from being monitored or controlled. The Enclave Trusted Broker. This creates the basis of a trusted relationship between itself and the Enclave Trusted Edge. It includes its own root of trust cipher key generator to create layer 2 over layer 3 tunnels. And last is the Enclave Trusted Edge. The Enclave Trusted Edge is an endpoint device that cryptographically secures devices and enclaves connected to an Enclave Trusted Broker or point-to-point to another Enclave Trusted Edge. The Trusted Edge is the device that would be inside, in a location where you would put a camera or a PLC or a door sensor or other equipment that would be connected to another trusted edge, all on the same IP addressing or even a routed environment. And this is an overall idea of how all of this works. So you have the Enclave Orchestrator here, the trusted broker, which is where all the secure tunnels terminate. The trusted edge devices are, you see the camera, icons in here and here. These devices were the ones that connect to each other. Then we have our discovery and monitoring service, which has smart alerts, smart DHCP and DNS and NTP services. It is our rules engine for monitoring. It connects back through the trusted broker and the orchestrator to provide monitoring of events. This is a different way to look at how it works. And I did this slide specifically to illustrate that there is a relationship between devices and how they work with each other. So in the top corner, you have the secure blockchain. Then you have the administrator console. This registers back to that blockchain, as I mentioned earlier, and it has the software bundles. Those software bundles are signed and can only be used by the devices where they're installed. And you have the orchestrator console. It's registered to the blockchain and it's owned by this administrative console. The orchestrator console is the policy engine, as I said previously, for secure devices. You have the trusted broker, you have the trusted edges, the secure tunnels here, the devices and the command and control subnet illustrated. And there again, we have the trusted DMS. I'll be showing these components to you shortly. I'm going to switch slides or switch to my browser. And here is actually the Enclave Orchestrator. And what we have is on the left, the frame on the customer section, and then the administrative settings of the Enclave Orchestrator. Here's where you define secure enclaves, where you have the devices that are part of this orchestrator, and then you have the alerts section. Because there are a large number of alerts in this system, over here at the CyberBytes Foundation on the second floor lab, this takes a moment to display. Now I'm going to go back to the secure enclave section. Adding a secure enclave is very simple. You click on the plus sign and everything starts working. You do this, wait a few seconds because it's querying other devices and verifying ownership. And again, this also will go back to the blockchain when it's completed. You provide a name of the enclave, you select a customer, you select a DMS, discovery and monitoring system. The sleeve ID, that's the actual enclave number. These have to be different. You specify subnets that would be inside the secure enclave, the session key time, and the connection parameters. I'm going to go back to an existing enclave, and this is the one that's here at the CyberBytes Foundation, in the same room with the ICS Village Wall that Tom Van Norman, who did such a wonderful job introducing me, operates. So here we have the details. This is the topology section, which has the trusted brokers, and then it has what we used to call gateways, we now call trusted edges, and what we call bridges here, we call trusted brokers. These are the secured trusted edges on this floor. And behind these devices are cameras, laptops with Wi-Fi adapters. There's a Wi-Fi modem in the ceiling. And then we have the controls for the topology. There's one to approve the topology and one for trusting devices. A user can have the right to approve a topology, but not have the right to trust all devices. I'm signed in with a super admin account, so I have all the privileges. But again, I can provide least required access to a user, and they can create a topology, and then that person's manager can then approve the topology. And this section is the device section. These are embedded gateways and unmanaged devices. Most of these devices here are access cameras or the Wi-Fi units, as well as the MAC addresses of the trusted edges. They came back in itself. I'm going to now jump to the DMS. The DMS, being the rules engine, has to communicate back to the orchestrator and needs the software ID of the orchestrator to integrate. When that is done, you perform a discovery. And so I performed a discovery on the CyberBytes IoT Lab. That discovery gets pushed back into the orchestrator. And then that's where I get these other devices to put into the secure topology. There's the alert section here. And then this is the enclave section. This is what this comes back from the orchestrator. When this is populated, you're able to create a rule set, and then that rule set can fire. And then based on the code, for example, these are unknown devices. Yes, it shows manufacturer not found. That's something I'm working on to get that manufacturer information added in. And then it shows the date of when that alert was fired off. Those alerts get cross-backed in through the API to the alert section here in the orchestrator. Now there's additional information that I'm grabbing from the trusted brokers. We have our management and monitoring troubleshooting tool, which these functions will be integrated into the DMS coming, in the near future. One of these things I have here is a Sankey diagram showing the communication of devices in the secured network. You'll see multiple types of IP addresses. You'll see these 50.102 IP address or 50.101. These are devices within the secured enclave. The 172 addresses, these are the IP addresses on the actual trusted edge devices. This is why I said this is a tunnel within a tunnel environment. What is actually happening is we create a tunnel, the outer tunnel with the TLS 1.3 connection. We then create a layer 2 another tunnel inside using UDP 820 or another UDP port, so you can get through, in case there's a problem with the firewall. And then that tunnel is where you put all the bearer traffic. So all of that traffic can be passed over at layer 2. Now you can also put a router behind a trusted edge device and allow multiple subnets within an environment, or you can have a flat network that's geographically dispersed. And in this slide, I'm showing you some of the layer 4 destination ports that are inside using the same information that's in here. And I'm also using the same components on the trusted brokers that generate the data for the alerts in the DMS. Those are coming back into these slides, this dashboard here, showing the layer 7 protocols by name, the total counts and percentage of traffic, MAC addresses in terms of a COM matrix, and the overall devices inside the secure enclave based on the time. Again, that's within the past 3 hours. So these are the components that we provide as part of our solution. And if I can switch the camera, I can show you some of the devices in the lab, or Tom can help me. Let's see now. I appreciate your patience. So I've changed to a different camera. And in this camera here, so that's one of our trusted edge devices here in the IoT Lab. That's a management laptop. That's our server backplane, as well as additional devices. The 2 blue boxes are our trusted brokers. The red box is the trusted orchestrator. There's a Wi-Fi router for inside the secure enclave. And in addition, we have Li-Fi laptops on the left. And the whole point is this part is to have different partnerships with organizations in furthering IoT, ICS education, as well as our alternative, thinking outside of the box in terms of security. And the last slide I'm going to share is basically my final comments. Enclave works to make the cyber part of cybersecurity more affordable. We believe in a holistic approach to IoT ICS security. It's not just cyber. Communication is key. Dejargonization of solutions help with customers and end users. It's one of those critical pieces that I've learned in dealing with trying to do deployments for a public works facility. Partnerships with other organizations and the end customer are critical. Thank you very much for attending. I am happy to answer any questions that anyone may have.